All right, let's go ahead and get started here. I'm not sure why the talk's not showing up. Do I need to do something over here? All right, well, we're getting the technical issue addressed. I have a couple of questions for you guys. Any JavaScript developers in the room? All right, perfect. And anybody working with Node.js already? Okay, good. This is the perfect room. Sorry, I'm not going to stand because the video cable wouldn't reach. I'm going to sit here instead. This is understanding async processing and patterns in Node.js. Brief safe harbor statement. Please don't make any purchasing decisions based on what I say here today. So we've already covered a little bit about you guys, so a little bit about myself. My name is Dan McGann. I'm a developer advocate at Oracle. I focus primarily on the JavaScript and Oracle database communities, which means I spend a lot of time working with our Node database driver for Oracle, but there's actually some new and interesting places I get to work too. For example, we have an MLE engine now in Oracle database, as well as MySQL, which is being used to execute JavaScript within the database. Cool stuff. I have my contact info here, and of course these slides are already available via the schedule online, so if you want to download the slides, feel free. If you have questions for me related to this or other JavaScript and database related topics, please feel free to email me and reach out. So what is Node.js? What I have here is a screenshot of the description you'll find if you go to nodejs.org. And there's a couple interesting pieces of information that jump out here. So the first is that Node.js is a JavaScript runtime built on V8. So prior to Node.js, JavaScript pretty much just ran in browsers. One of those browsers was Chrome, and Chrome's JavaScript engine was V8, or is V8. And it's known to be one of the very best JavaScript engines in existence. And so Ryan Dahl in 2009, basically with a few others, took V8 out of Chrome because it was open source and then plugged it into Linux, allowing folks to execute JavaScript now on the server side, not solely in a browser. And this was very interesting. The demo that he did was building a web server with just a few lines of code. And when he ran the demo, he got a standing O because, oh my gosh, folks that knew JavaScript could now build web servers. What could be cooler than that? What else stands out? Well, it's the largest ecosystem, or that NPM provides access to the world's largest ecosystem of open source libraries. So just by using Node, you have ready access to tons and tons of code that you could use in your applications to make you more productive. That's pretty cool. What about this part? Event-driven, non-blocking I/O. Ooh, this is where things get a little bit more complicated. Now, when Ryan Dahl was making this tool, this platform, back in 2009, he often said that JavaScript was the perfect language for this because JavaScript was sort of evented already, was written for this kind of thing because of the way that the web works. But what does that mean? Well, here we see some example code, and I could run this. It's just a very simple web page that shows a button. And when you click the button, it says, hey, the button was clicked once. And when you click it again, it says the button was clicked twice, that kind of thing, right? And of course, it's evented because we have methods like you see here down on line 17, button.add event listener. But it's more than that. In JavaScript, functions are first class. Now, some hands went up earlier when I asked if anyone was doing JavaScript. Does anyone know what functions as first class, functions are first class means? Can anyone call out a line or two here which demonstrates that functions are first class? Just scream out a line number. There's a 1 in 23 chance you'll be right. It's these lines here. So in JavaScript, timing is everything. And what's happening here, this function, I'm losing my mouse, here we go, this function, I'll just use it over here, onLoad is being declared on line 7. And this function onLoad is being passed to another function call on the document down below. So document.addEventListener, and then we pass a string, and then we pass a function. Not all languages allow you to pass functions like numbers and strings and arrays and so on. That's what functions as first class means, that functions are just like any other data type. They can be passed around and invoked in the future. We're not invoking on load here. Instead, that function will be invoked in the future. The same is happening with onClick. So that was cool, that helped. Well, what else helped? Well, the fact that functions in JavaScript provide closure. And this is kind of another necessary ingredient for what we're doing here with async work. Does anyone know what that means? Can anyone call out a line number that would show that? So it's here. The way this works, we have a function called onClick. And in that function, we are referring to variables that were not declared within the function, but rather in an enclosing function scope. Now here's the interesting thing about JavaScript. We're taking this function called onClick and passing it to button.addEventListener click. And we're basically saying that when this button is clicked, invoke the function onClick. And JavaScript says, because this function onClick is referring to variables declared in the outer scope, I'm going to create a closure around those variables, and I'm going to guarantee that the function has access to them when the function is invoked. And this is unique and different, but these were necessary for evented programming and already there. Now, despite JavaScript being so well and purpose-built for event-driven asynchronous programming, when Rising Stack recently did a survey on Node.js and asked folks, what Node.js topics are criminally underexplained, the results varied quite a bit, but 3 of these kind of really stood out to me. And they were asynchronous programming, the event loop, and promises, which are all kind of interrelated. In fact, you could just say asynchronous programming. And in fact, some of these other things are also related to that, but these are the primary 3 that stood out to me. And why is that? Well, in JavaScript, try, catch, finally is in fact a thing. You can do it. And so what do you think would happen if we ran this code in a browser? So we have on line 3 here, well, let's go through it. So in the try block, we're saying try 1, log that out to the console, then throw an error, and then log try 2. We catch the error, and then inside of here we log catch 1, we throw a new error, and then log catch 2, and then finally we just log finally. What do you think you would see here? So would we see try 2? That wouldn't make sense, right? We're going to come out of here, we're going to fall into the catch block, we're going to see catch 1 obviously. Are we going to see catch 2? No, because it's going to throw an error, it's going to come out, ooh, what happens here? Are we going to see finally? Yes, because that's what try catch finally is all about. Make sure that you run the finally block prior to letting the error that may bubble out of the catch block proceed up the stack. So that's cool, but, this is a big but, you can't actually use try catch finally the majority of the time you want to within JavaScript. And the reason is you're doing asynchronous work. So for example, you want to get a connection to the database. You want to use it to do some work and catch any errors that might occur and then close the connection. Here's the thing. The asynchronous work is not being executed in your single thread here. That asynchronous work is being offloaded, run in a separate thread, and then when that thread is finished doing the asynchronous work, then your callback function gets executed on the main thread again. And you cannot catch exceptions that occur in a separate call stack. Just can't do it. Other things are like common things you might think are going to be easy, like doing a loop. Let's say you want to just do a simple synchronous loop. You want to loop and process some rows, and then when you're done, you want to do the next thing. Well, it doesn't work like that in Node.js because each of these loop iterations is actually an asynchronous call, scheduling work for a separate thread. So it's tough. It just doesn't work like you'd want it to. So how do you do async flows like this with Node.js? Whether you want to do something sequentially, whether you want to do some things in parallel, or even combinations of these flows, how do you get it done? Well, you got to learn a little something about the event loop in Node. And I say a little something because really the level of detail that's out there is sometimes maybe too detailed. But in case you like that level of detail, I'm pointing out not only this video, which is everything you need to know about the event loop in Node.js. This is a great video that explains it in detail, but not too much. It's about less than 20 minutes. This video as well, and one is kind of a top-down approach, one's a bottom-up approach, so you learn a lot just by watching these videos. But I'll cover some of what they cover just very quickly. So the way that Node.js works, it is built on top of another C-level library called libuv. It used to be built on back in 2009 when it was just for Linux. They used a library called libaio, and the AIO stood for Asynchronous I/O. So that only worked for Linux. They needed something that worked cross-platform. So libuv came around, and libuv offers the event loop that Node.js uses to execute the JavaScript code. And it basically defines 7 phases on its website. If you go to the Node.js website, and I have links here at the bottom you can use to get more detail on what I'm showing you, you'll see that there is a corresponding event loop, of course, because it comes from libuv, but they've simply collapsed idle and prepare into a single phase. And then I went ahead and created my own for the purposes of this talk with just a bit more detail. So this is my version. Now the first thing we're going to do is point out that idle and prepare are only used internally in Node, so your JavaScript code doesn't use this particular phase. So we get rid of that one, simplify it some. So what's left? Well, we have timers, and basically timers is a phase where if you make a call to set timeout or set interval to basically schedule some work to be done in the future, well, this is the point at which it will be done. Node is going to look at the various timers, figure out which ones have passed and need to be run. It's going to take those basically C functions, which have a pointer to the JavaScript function that was passed to it, and it's going to queue them up and execute them and then move on to the next phase. So then it goes on to pending I/O callbacks. And I almost removed this one, but it is kind of relevant. So basically, sometimes you have certain operations like TCP errors that don't get executed during the normal time they would, which is down here in the poll phase. And so they're scheduled for the next iteration of the event loop instead. Okay. Now this is the big one. This is the poll phase, where you're basically polling for I/O. And I'll show you a little bit more about that here in a second, but basically there's 2 types of I/O. There's evented, which is efficient, and then there's thread pool, which is not as efficient but necessary. But either case, it's polling for I/O, and this is where the majority of the callbacks that you're specifying are going to get invoked. Then there's another poll, or queue rather, in the check phase for work scheduled via set immediate. And then you have work that you may have scheduled when you grab an object and you say, on the close event, then execute my callback function. Okay, that gets executed at this particular phase. But what about process.nextTick, which is a function we can use as well, or promises, which allow us to basically resolve things in the future? Well, they happen to have their own queues, and they're executed after each of the phases you're currently looking at. Like, so it kind of looks like this at the end of the day. So you just have one queue for your nextTick stuff, one queue for your promises, and so it goes through this queue, into this one, goes through this queue, into this one, into this one, into this queue, and so on and so forth. This is basically how Node works. The truth is you don't need to know all that level of detail, although these slides may prove useful in the future when you do need it. But when you're starting with Node, as most of you would be, you don't need it. What you need to know is that, first of all, your asynchronous code must call some C layer of code. So set immediate and process.nextTick, we use those in JavaScript land, but ultimately they're going to be calling some C layer API. And the reason for that is because libuv is a C layer API, so it needs to be in C. Now, the important thing to know about libuv is how it separates work. And the first grouping is this network I/O, as well as the timers you saw. So network is evented, meaning it uses kernel-level APIs to do what it does. And this is what Ryan Dahl was really trying to do, build a platform that, on the other hand, you have file I/O, certain DNS operations, and then user code, which is a big bucket. These are going to use a thread pool. Now, I created this diagram I'm going to show you before many moons ago. In the first video that I showed you before, you can watch later, the presenter said, you know, everyone does these diagrams of the thread pool and they're always wrong. And he's right. My diagram is not correct entirely. It's not entirely accurate, but it is useful for simplifying and understanding how async processing works in Node, so I'm going to keep showing it anyway. And the way it works, your JavaScript code runs in a main thread, and that's essentially the event loop, right? And you're going to make some async API calls, like maybe you call set timeout. As I mentioned, that's evented. Maybe you make a network callouts to request a web page. That's also evented. TCP and UDP, completely evented, kernel-based, really efficient. Maybe you're reading or writing to a file, so you're using file system APIs. Maybe you're doing a DNS call translating google.com to an IP address, or maybe this user code here is a really big bucket and basically includes things like any third-party module that you npm install, such as the database driver that we use with Oracle, or if you're doing some kind of compression or encryption, these types of things utilize a thread pool. The reason being, if they stayed and did that work on the main loop, you would be blocking. So imagine this main loop is processing thousands of end users that are using your APIs or your applications. This main thread, this single thread, is more than capable of supporting many, many users as long as you don't block it. As soon as you block it, you're basically killing your Node app. That's why we schedule this work to be done asynchronously. So this, the kind of logic you'll find here is always very lightweight, you know, if, then, else, simple loops. But if you're doing heavyweight stuff, you offload that to one of these areas. Now, when you make an async API call, such as set timeout, in JavaScript you pass a callback function. And that's been true up until only very recently, but it's true still for the most part. You pass a callback function that should be invoked when the async work is complete. So what happens, the async work is done. When it's complete, your callback function is then added to some kind of queue, which this queue doesn't really exist, as we saw before. It's more complex, but it's a simplified version. So the callback function will eventually end up at the front of the queue and then hop back up here on the main thread to be executed. And think back to what I said before about why you can't catch an error, right? Now, hopefully, it's a bit more clear. The main thread is where the error occurs. But the async work that you were doing was not in that thread or being processed there. The async work might have been here, and then this callback function comes along with the error that occurred, and it's too late. You can't catch that anymore. So there's different types of async flows that you might be working with. The one I'm going to focus on in terms of a demo here is going to be the one header detail transaction. It's a simple type of interaction that I think most of us done in the past if you've ever worked with databases, where imagine you have a parent-child table relationship, and you want to insert some detail records into the child table, but first you have to insert the parent. That will give you the primary key of the parent. Then you can insert the child records with a foreign key relationship to that parent, right? It's like a two-step process at minimum. So we'll be investigating that, but there's other types of flows, like maybe you're doing some kind of ETL process from the database, and for that you want to transform an API call, write it to a file. There's lots of different flows you could do. They're all supported in Node. The approach you might use may vary, and we'll look at a couple use cases of both. Let's start with the header detail scenario. And just imagine that we have some API endpoint. It's, the endpoint is some URL/API/orders. And the idea is that somebody is going to issue an HTTP post against our URL endpoint. And what we need to then do is define some logic. This is the data they're passing us. Very simple. The top level is a parent thing, just a name property. The details is an array of child things with just a name property. And the goal for us is to get this data into the database. right? We're going to explore a couple different options to do it. Now, to do this work, I'm going to be using the Oracle database driver for Node.js. It's known as node-oracledb. What you're seeing here is a class overview. I won't go into too much detail. I'll just start by saying the base class is used to do two things, either create a connection pool or a one-off connection or a dedicated connection to the database. Whenever you're creating something like an API, you always want to create a pool first if you want the API to be able to scale and perform well. And then once you have your pool, you get connections from the pool. It's the connection that you use to do the bulk of your work, such as inserting rows into the table, as we'll be doing here. But also, you can do all kinds of SQL and PL SQL using the connection. And we have other objects like result set and lob objects for streaming data into and out of the database when you're doing more complex operations. So let's start by looking at Node.js style callbacks. And back in 2009, this is really the only option you had to do async work in Node, because this is kind of how JavaScript has always done async work with callback functions. But when they went to approach the callback functions in Node.js, they said, hey, let's not do the free-for-all that everyone's been doing up until now. Let's define a couple of rules. And they were pretty good at following these rules. The two basic rules are, A, the callback function, when passed to an async API, is always going to be the last parameter passed. And that function, its first parameter, is reserved for errors. And you can do this with named functions or anonymous. We'll see examples of both. But here's what this looks like. So we have at the top here an async API being defined. And this is just a simple JavaScript module. And I'm exporting or making public from the module a function called getRandomNumber. And it's a simple function. It takes in a number of milliseconds and a callback function. And in order to invoke that callback function in the future, I'm using an async API here called setTimeout. So I use setTimeout to invoke the function after a certain number of milliseconds has passed. And note here that when I invoke the callback function, I'm passing null. Null, when I invoke the function, that first parameter is reserved for errors. So if an error doesn't occur, then we pass null instead. And then I pass a random number. So down below, you see me using this module. I'm requiring in the file from above, async API, and then I'm invoking the function that's been made public, passing the number of milliseconds as well as the callback function. So all I do is log that out after a number of milliseconds has passed. Now, what you're not seeing in the use of the API is proper error handling. And this is what that should look like. So now, when I invoke the function, what I have to do is check to see if the error parameter has a value. And if it does, and the API implementers have been following the correct standard, it will either be null, indicating nothing happened, or it will be an instance of error. And so down below, you see I'm checking to see if error, because in JavaScript things can be truthy. It can be a simple check like this. If error, then console log the error, or console error the error, and return. And this is really important. We're short-circuiting the logic of the function. We're exiting the function because an error occurred. And if we get past this point, if we get down to line 9, we can assume that the async API successfully completed, and then we continue our success logic. Any questions so far? All right, so this is the Node.js style, and this is what it looks like to implement our solution. Remember, we have a REST API. We're expecting a post call, so I have a function here called post. And it's going to take in the order, and the order is that JSON you saw before, and it is going to pass a callback. And this callback is something that we're going to invoke in the future when the header and the detail rows have all been inserted successfully. Now, I've collapsed this function. It is, in fact, about 110 lines of code. But this is what it looks like from a high level. I'm going to go into some sample code here, and we'll see what this implementation actually looks like. So we're doing anonymous callbacks first. All right. So here's our function, post. And note that above I'm bringing in the Oracle database driver, also a configuration file so we can get a connection to it. But we have the driver and we call getConnection. Now note, when I call getConnection, I pass that configuration and I pass a callback function. The callback function is following the pattern we discussed before. The first parameter is reserved for errors. When that function is complete, it will be invoked, the callback function. I'll check it for errors. If I don't have an error, I can assume success. I now have a valid connection. Now I'm going to use that to execute an insert statement using the data that was passed, that order object. I'm using bind variables here for both security and performance. And again, at the end of the execute statement, what are you seeing? Yet another callback following the same pattern. We check for errors. If there wasn't an error, I can assume success and continue on. If there was an error, maybe I close that connection and exit out. But assuming success, we now have the result of the previous call, and I get the header ID, and I use that then to start inserting detail. When this insert successfully completes, this callback will run, and I'll insert the second row of the detail. And when that successfully completes, I can then insert the third row of the detail. Down below that, you're starting to see what in Node.js we call the pyramid of doom. So basically, it's callback functions nested in callback functions, nested in callback functions, and you start to see how it comes in here. This is the sort of inverted pyramid here, and it can be a real mess if you approach your Node.js applications like this. Using anonymous callback functions is not going to result in maintainable applications. So you know what? I meant to show you at the very least that that's working. So to show you that, I'm just going to open up a terminal here. And before that, I'll show you in SQL Developer, we'll open a connection to my local HR schema. And I have this header table with no data. Oops, we have data. And I have a child table called detail. All right, that one's empty. Let me go to header. We'll just delete these rows, commit that. Okay, so now all the data is gone. And I'll go back to my terminal here, and I'm going to call node test1. So this is a test file that I've written to specifically test the first implementation of the code using anonymous callback functions. So I run that, it says it's done, we refresh this, and we have our parent thing, and the child things are there as well. So, cool. It actually worked. That's about the only good thing I could say about that code. On the bad side, is there a question? The question was, is the code running on the server side or the client side? And the JavaScript code that I wrote was running on the server side. Node is a server-side platform for JavaScript. So when we talk about client versus server, that term actually means different things in different worlds, right? For Oracle, the client is often what some folks would call the server. So in this particular case, it wasn't running in the browser. That's probably the best way to put it. Running on the server. It was not running in the browser. It was running on my Mac, my machine here. I could run it on Mac, Linux, or Windows, but Node does not run in the browser. I'm not sure I understood the question. Maybe that's one I can take after the talk? Thank you. All right, let's move on to the next implementation. This is header detail with named functions. So we saw that there were some issues with anonymous functions. And we can stick with this Node.js style callback pattern, but do a little bit better just by giving our functions a name, which allows us to call them by name. So you're seeing here at a high level what this looks like. I now have a post function. I have a create order function and create details function. Now, one of the issues with the anonymous pattern was that I had a fixed level of children, But what if I was passed 4 instead of 3 or 2 instead of 3? That code couldn't handle it, but at least now, with a named function, we can handle this situation correctly. So we'll take a look at what that looks like. The next pattern is named functions. And I can make all this code available if anyone wants to go through it after the talk. So just like before, only now we get our connection, and then we come down and we invoke a named function, createOrder. CreateOrder is defined down here. Now when we invoke createOrder, we have to pass along some state, such as the order that we want to create, the connection that we had just gotten. We pass those along, and then connection.execute can insert the header row. When that is successfully created, inserted, then its callback function will invoke createDetails. Note what it's doing here is passing the order details, as well as the header ID that was retrieved, and the connection, again, that came from the first function. So it passes that, and then createDetails checks this index parameter, which defaults to 0. And as long as it doesn't equal the length of the array that we're inserting for the details, it'll continue to iterate through here using manual recursion. So we see the name of the function here, createDetails, and within it, in the success callback, we're again invoking createDetails to insert as many child records as necessary, but we're doing this work synchronously, one after the other. I'm just going to leave these slides like this because I think it'll be a little bit easier than toggling back and forth. So once we moved to name functions, we got a whole lot less nesting, so we're avoiding the pyramid of doom. There's a question? The last parameter was not a callback in the previous example I showed. So it's basically when you're in, oh, you know what? Good call. I'm gonna give you that one. So in this case, I am the implementer of the API, and I've basically made a bad decision here. So I'm gonna update this code after this talk and switch the position here of these two parameters. I'm sorry? No, it's almost like a rule that is like a handshake, you know? You're supposed to, when implementing async APIs, follow these standards, but there is no enforcement. Is that the same as what? That's correct. It's the same as error. So those two rules that make up the Node.js style of callbacks are not enforced by any means. And in fact, the implementers of Node.js did not follow them 100%. We all make mistakes. All right. So some good things, less nesting. We could handle arbitrary collections, also fewer lines of code. On the bad side, the functions were tightly coupled. The way we had to pass around state wasn't great. And nobody likes manual recursion. That's never fun. So what else can we do? Well, there's a module in the community called Async. And Async is a really powerful module. One of the most popular libraries in Node.js. It's really easy to install. npm install async -s save to add it to your package.json. And once you install it, you then have access to about, well, around 70 different methods to work with async types of operations. Some of the more interesting ones, well, they group them into 3 different groups. You have functions for working with collections or arrays of data, functions for setting up the control flow through which your application needs to work. And some of these have similar names. They're just into the different buckets. And then there's a utility set as well. But you'll mostly be using functions defined here. So using the async module at a high level starts to look like this. So now I have a single function called post. And within it, I'm using the async module's series method. This is a control flow method. And I'm passing it an array of functions. And basically what happens, async is going to execute each of these functions in the array for us one at a time. Now, how does it know when it should go to the next function? Well, it passes us a callback and expects us to invoke it to tell it to go to the next function. And if we pass that callback an error, it skips the rest and instead invokes the second parameter after the array, which is sort of the function that'll be invoked at the end, or if an error occurs and it gets past the error as the first parameter. You can think of async as a library that builds on top of the Node style of callbacks, but exposes a lot of really handy methods. So once you know how Node style callbacks work, and you combine that with the async module, you pretty much have all that you need to do some of the most intense kind of async operations within Node.js. That's all you need. So we'll take a quick dive into that, see what it looks like. Now the truth is, at that high level, you were only seeing the control flow method series, which was working through the different series of functions. So the first function here gets the connection. I invoke the callback that I was passed, so then insert header can go. It inserts the header, and then I get down to insert details. Now you're seeing a second method in async you didn't see before called each series. This is one of those methods that doesn't work for control flow, but rather for arrays and collections. So I'm saying each series, for each detail and the order object, invoke this function. So no matter how many elements are in the child array, it'll invoke this callback function and insert a row into the detail table. When all that's done, I can commit the transaction. And if an error occurs, I'll just close the connection and exit out. So the good with async is that you can really keep nesting from going too far. It makes working with control flow and asynchronous array processing much easier than it would otherwise be. But at the same time, it might just be another form of callback hell, because you can't escape these callback functions. That's correct. The question was, is every record insertion a callback? Essentially, yes, because it has to be done asynchronously, because we can't block the main thread. And anytime you do asynchronous work, you have to pass a callback. All right, let's move on to the next thing. So basically, we're getting into promises now. Now, promises are a new... Oh, sorry, another question. Sure? Mm-hmm. So the question was, if an error occurs somewhere in this array of functions, and our final function is invoked and passed the error, how do we know where the error occurred up here? Well, don't forget that you are in fact invoking the callback function that async passes you. And so you are passing along the error that occurred. So if that error is in fact relevant and you want to track it at that point, you could do some kind of execution. Perhaps you have a logging framework that you're using and invoke the error method in the logging framework to make it more obvious. Otherwise, you can inspect the error down here, and the error message itself may be somewhat indicative of what went wrong in the processing. It really just depends on the situation, but there's certainly options to handle it. Could you repeat that? You know what? Let me take this question after, because I'm down to just a few minutes, but I'm happy to address that after the talk. All right, so the way promises work. Now, what we've seen thus far, callback functions are, of course, a part of JavaScript, and Node just has their own style for working with them. Async is its own module, but JavaScript started to advance. In fact, it was driven by the community, which started to create modules for abstractions on async work. Things like promises and deferreds became a thing, and it was all kind of tricky, and some libraries implemented these things differently than others, and all of a sudden, at some point, it became part of JavaScript, and it was standardized and simplified some. We got these promises to work with. Now, promises are just objects that can have one of three states. They're either pending, resolved, or rejected. So they go from pending to resolved if everything is good. They go from pending to rejected if some error occurred. And promises have methods like then and catch. Then gets executed if the promise is resolved. So you pass a callback function to then, and it'll get executed if the promise is resolved. Rejected invokes what you pass to catch. And promises, when you invoke then and catch, they return promises, so you can chain these and construct a flow of promises. And if we use promises to solve this problem at a high level, this is what it would start to look like. So now no third-party library. What I'm doing instead, I'm calling OracleDB get connection. Now our APIs with the driver are overloaded such that if you do not pass a callback function as the last parameter, we assume that you wanted a promise returned. So it's like going from one pattern to the other, and the only thing you have to do to tell us that you want a promise is don't pass us a callback, and we're assuming you want to use a promise API. So get connection here returns a promise. And I use then here to say what should happen then if we get a connection successfully, and it'll be past the connection, and then it can do something with it. And that'll return a promise. And if that goes successfully, then the next then is invoked, and that can do something after that. Now, if an error occurs somewhere in this chain, it'll skip the rest of these thens and go right to the catch function that I specify here and invoke that logic instead. Question? Why do promises even have a state parameter or property? Mm-hmm. Let's look at the actual code and see if it makes sense once we get into it. Because that's sort of the 30,000-foot view. So in this case, I'm calling get connection, passing the configuration, and get connection returns a promise. A promise has then and catch methods. So I can chain off of this then, and I'm going to, in this function, return another promise, right? Promises are getting used. Well, the way I'm using the promise is simply to use the then and catch methods. Why do promises? I'm not sure I understand the question. Promises do have a property that indicates their state, but I'm sorry? 3. Correct. Right. Why does a promise not have an executing or running state? It's an interesting question. I've never considered it before. Perhaps there are promise implementations that do. As I said, when promises were implemented in JavaScript as part of the spec, things were simplified some. Some promise implementations have a concept of an object called a deferred. Frankly, I'm glad things were simplified some, and I'm not sure that having such a property would in fact be beneficial, but maybe there's a use case for it. I couldn't think of one, at least not right now. Can I show you the catch? Sure. So very quickly, we go through the then. Here you see something kind of awkward. I need to get through the details array. I'm using a synchronous for each loop, and I'm building up what's called a promise chain. So I have to kickstart this chain invoking a function called promise.resolve to basically get me a promise that's already resolved. Then I go through the loop building up my chain. I take the promise chain, I set it equal to itself plus a then call. And then I can do my async operation. And basically, you can think of it as I'm winding up some things that need to be done asynchronously, and then the promises as they are executed will be unwinding themselves. But they're no fun at all, quite frankly. So we wanted to see the catch. I'm going to show you that down here. This is at the very end. I'm catching any error and just logging it out. But frankly, I'm going to come up just a little bit. You're going to see a then call here where I pass 2 functions. The first, if you pass two functions to them. The first is meant for success. The second is meant for error. So there's two ways to handle errors with promises. This is the second way. And so what you see I'm doing here, if any error occurs above, I roll back the transaction and then continue to close the connection and catch. Frankly, this isn't my favorite of the implementations, but this does in fact work. So it looks like we're out of time, but I haven't even gotten to show you async await. So I'm going to show you async await in less than 60 seconds. So async await is basically a new feature of JavaScript that builds on top of promises. So unfortunately, guess what? You can't escape promises. And that means you can't escape callbacks. So you kind of have to learn these previous things before you can finally get to async await. But here's the beauty of async await. Even with promises, I still had about 80 lines of code. The async await implementation got it down to about 60. Now, you remember before when I said that try, catch, finally doesn't work? Guess what? It works again. Do you remember when I said that an async loop isn't something that you can really do in JavaScript? Guess what? You can do it now. So here's an example of both. Basically, with async await, you put the keyword async in front of a function definition. And that means within that function, you have another keyword called await that you can use. Now, if you're working with an API that returns a promise, basically, the way it's called coroutines, the execution of this function will stop right here. It'll do the async processing and then return the result from the promise. This allows us to write clear, concise code without all these crazy callbacks and such. But you have to really understand and know what's actually happening behind the scenes. This is, in fact, still executing asynchronously as it was before. Just the execution of the code looks more synchronous. So then we get our result from the header, nice and clean. Here is a synchronous loop. I'm using await within the loop, so it doesn't go to the next iteration until the previous one finishes. And then finally, we can commit. Anything goes wrong, we'll catch it, we'll log it, and finally close the connection, and we're out. Oops. That's correct. It's not necessarily one callback. There were probably a couple of callbacks in that code, but ultimately, with async await, because it builds on promises, we can almost avoid a lot of the callbacks you would have seen before and start to get code that reads clearer and still executes as it was with callbacks. There is more. Once you learn those basics, you'll get into things like streams. We do support streams with the driver. There's other libraries such as RxJS, which you may have heard about. It's a completely different way of thinking about asynchronous programming. It's not like bringing in a library like you might have done with jQuery in the past, but rather a completely different way of doing things, more like Angular would be. I will, however, point out that although it's getting more popular, RxJS, it's still nowhere near as used as async. So learn async first and then consider RxJS perhaps in the future. In summary, there's no perfect solution for async work in Node. At a minimum, learn the callbacks, promises, and async await, and then perhaps take on some of these other libraries and classes such as streams when they make sense to do so. Are there any other questions in the back? So the question was, when we're, oh, I'm sorry? I'm not with you at all anymore. So do you remember when I showed you this slide before? And I said this is kind of like a high-level overview of the event loop, and I threw in at the very end the fact that next tick and promises have their own queues. So when you're saying .then and you're passing a callback function to .then, that's essentially the starting of some async work. And then when it finishes, it gets queued up for execution. Oh, I think all the thens had an argument. Oh, I see. It's basically, right. Yeah, right, exactly. So when one async function, or when one function that's executing in a then call returns a promise, the next then call will not be invoked until the previous promise is resolved. When that promise is resolved and the API calls something like get a connection, you'll get the result of the previous. I'll take it after. So I apologize. So for anyone who I said that to throughout this talk, if you have questions, please feel free to come up here and I'll take them after the talk. Thank you very much. Appreciate it.